Same idea. Let's start by just solving these. So I'll do this first one in red again. Two groups of negative 6x would be negative 12x's. Two groups of negative 7 is negative 14. Nothing else. There was no other distribution there, so I'm just dropping the rest. Combining like terms, negative 14 plus 2 is negative 12. So I now have negative 12x minus 12. And that's greater than or equal to negative 10x minus 28. Principles of equality. Now I'm going to do this one with some purpose. So I'm going to put the x's on the right, just so that my coefficient of x is a positive, and I won't have to worry about flipping the inequality. Plus, it's good to see that you can if you want to. So my number is going to be on the left. That means the negative 12x is on the wrong side. I have to zero that out by adding 12x's to both sides. And also the negative 28 on the right, that has to be zeroed out by adding 28 to both sides. So that zeroes out these, and then the 28s. Negative 12 plus 28 is positive 16. Again, addition and subtraction principles of equality do not affect the inequality itself. Negative 10x's plus 12x's. See this? Just by choosing that the right side of the inequality forced that coefficient to be positive. So now, at this point, when I look to divide both sides by 2, I don't have to worry about flipping the inequality. Do you have to do it that way? Of course not. But now I have 8 is greater than or equal to x. And again, just like we did on the last problem, before I graph that, let's see what the next one produces for us. And we're still in an OR statement. So this one, I'm going to put the x's on the left, numbers on the right. Why am I doing that? Because again, my focus for this problem is to force the coefficients to be positive so we don't have to worry about flipping the inequality. So the negative 2 has to zero out by adding 2 to both sides. And then also the negative 2x is on the number side of things, so I have to zero that out by adding 2x, but to both sides. So that zeroes out, whoops, these terms. 4x's plus 2x's is 6x's, which is now greater than 28 plus 2 is 30. That's nice. These are coming out very pretty, but you probably should expect some fractions or decimals on the assignment. So now x is greater than 5. Okay, now this is an OR statement. If I need the inequalities, I would probably put an OR. You should put an OR statement there, okay? So if you ever get an OR statement that's going to work, and I don't know if this one will, possibly, no, I think we should only need one for this one. But if they're ever separate, make sure you put an OR statement between the inequalities like this, because we need one for the interval as well, if it's needed. All right, so 0 would be over here. I'll put 5 here, and then 8 is to the right of 5. So starting with the red one, that's 8 is greater than or equal to x. So that is a closed circle at 8, because it could equal 8. It's not eating the x, though, so this one goes to the left. And I'll extend that. There we go. Now the next one, x is greater than 5. So at 5, that's an open circle. But this one is eating the x, so this line goes to the right. Okay. We want, it doesn't matter if it's part of one or the other. I can see that this line goes all the way to negative infinity, and then over here to negative infinity. Just following on the red line, I can see it doesn't actually stop at negative 5, because negative 5, it's not part of the purple one, but it's part of the red one. So I can continue on to the red till I get 8, and then it doesn't stop at 8, though, because I can jump on the purple one, and it goes forever as well. So yeah, negative infinity to positive infinity for this one. If you were to look at that, you could actually flip it and say, well, x and 8. Remember that it's eating the 8, though, so just make sure that you can flip it this way. So if, like I did this strictly to make the coefficient a positive up here with the 2. But yeah, if you get confused by that, feel free to just flip it back around. Just make sure it's eating the correct direction. Yeah, the other thing about this is the graph. If you were to graph this, you don't want the circles here or here. What you're going to do, because you should do this by hand, is you're going to click on the left and then drag it all the way over to the right. The green line is actually the real graph that you would need on the assignment, because it's everywhere. It doesn't stop at 5. It doesn't stop at 8. The OR statement tells us it's all of those values. Yeah, I think this is where we would say, instead of the inequality, we would probably just write something like all real numbers. I could be wrong there, but I forget what the assignment says. I apologize.